Hello everyone, welcome back to the fast track revision series of UGC NET Electronic Science. So in this video we are going to learn about two concepts, that is race around condition. Okay, race around condition, and second is master slave JK flip-flop or master slave flip-flop also. Both are same. Okay, so these two concepts we are going to learn from this video, right? If you are first time to my channel, please consider subscribing and don't forget to hit the bell icon to get video notifications from my channel. Right, so what is race around condition? So I don't elaborate, right? So this is a video revision series video, so I'll get back to the point straight away. Right, so race around condition. So race around condition will occur. So race around condition will occur in JK flip-flop. Okay, when? So what are the conditions for the race around condition to occur in JK flip-flop? Later we'll see how to eliminate that race around condition. Okay, so that is the concept here. So first condition, that is J is equal to K is equal to 1. So for JK flip-flop, when you give the inputs J is equal to K is equal to 1, then only race around condition occurs. Second, this is very important. Okay, propagation delay, TPD, propagation delay of flip-flop is less than propagation delay of pulse width. Okay, so propagation delay of JK flip-flop is less than propagation delay or pulse width, sorry, not propagation delay, so not propagation delay, sorry, so less than the pulse width. Okay, so in this condition JK race around condition occurs, right? So third, when the flip-flop is level triggered. Flip-flop is level triggered. Okay, so race around condition generally does not occur in edge triggered flip-flop. So edge triggered flip-flop does not have race around condition. Very important point. This is also one of the important point which you have to remember. Right, so in these conditions, when you give J is equal to 1 and K is equal to 1, so we know that when J is equal to K is equal to 1, Qn plus 1 is equal to Qn bar. Okay, so if you take propagation delay of flip-flop is 10 nanoseconds and pulse width is 100 nanoseconds. Pulse width means the width of the pulse, right? So for how many seconds it will be there, right? So width of the pulse, right? So if the width of the pulse is 100 nanoseconds and but the propagation delay is only 10 nanoseconds, then what will happen after 10 nanoseconds? After 10 nanoseconds, suppose initially Qn, okay, Qn is equal to 0. Initially Qn is equal to 0. After 10 nanoseconds, the output Qn plus 1 will becomes 1 because Qn plus 1 is equal to Qn bar. After another 10 nanoseconds, what will happen? Qn plus 1 again becomes 0. Yes or no? Because pulse width is 100 nanoseconds, but the propagation delay is only 10 nanoseconds, and still you are maintaining J is equal to K is equal to 1. You are still maintaining the same input, J is equal to K is equal to 1 for entire pulse width, but pulse width is too much long and propagation delay of the flip-flop is very less. Then after 10 seconds again it will change to 1. right? So this process continues, and at the end of clock pulse, that is after 100 nanoseconds, we are not in a position to recognize what is the output of JK flip-flop. So JK flip-flop output is not known. Qn+1 is not known to us. So this condition where the output is unknown, because of this condition, then that type of condition is called as race around condition. Okay, so in order to eliminate race around condition, what you have to do is we have to maintain TPD, that is propagation delay of flip-flop, more than the pulse width. This is the only way. Okay, so propagation delay of flip-flop should be greater when compared to the pulse width, right? So this cannot be seen, right? So this should be done manually, right? So we can eliminate race around condition by using master slave flip-flop. Okay, so why master slave flip? This is very important point, so just remember this very important point. So why master slave JK flip-flop is used is to eliminate race around condition, RAC will say, to eliminate race around condition practically. To eliminate this condition practically, we are going to use master slave JK flip-flop. Okay, so in master slave JK flip-flop, we are going to use two flip-flops. Okay, two JK flip-flops. So JK Q Q bar, JK Q Q bar, both are negative edge triggered only, right? So JK is directly here, and clock pulse is taken to this, and an inverter is used in the middle. This is the configuration, and the outputs of master is given to slave. So after all, master is given to slave. So in master slave flip-flop, this flip-flop will serve as master, and this flip-flop will serve as slave. This flip-flop will serve as slave. Okay, so output of clock pulse of master is directly applied, directly, but clock pulse of slave is given with inverted clock. That is, if master flip-flop toggles in negative edge, because this is negative edge flip-flops we are using, so master flip-flop, if it triggers in negative edge, then slave copies the output of master, slave copies output of master, but changes its state in the positive edge only, because it is given with a inverter here. So inverter, so here it is taken with inverter, so it will change its output only in the positive edge only, right? So even though there is a toggling here, suppose if the same condition, if you take 10 nanoseconds and 100 nanoseconds, if you take, right, for example, right, so when you are giving J is equal to K is equal to 1 for the master flip-flop, I am talking about master flip-flop, and suppose Qn is equal to 0, so when you give J is equal to K is equal to 1, after 10 nanoseconds you will get Qn+1 is equal to 1. So immediately the output of the master will be transferred to slave. So output of the master will be transferred to slave, that is Q is equal to 1 is transferred here, and Q bar is equal to 0. If Qn+1 is equal to 1, then Qn+1 bar is equal to 0 automatically. So these two outputs of the master will be transferred to slave immediately, because they are short circuited, right? So the outputs are short circuited, that is the output of master is given as input to slave. So immediately whatever the output you have got here, right, so Qn+1 bar is equal to 0, so immediately they are transferred to slave. So for slave, okay, for slave, then qn plus 1 will be 1 and qn plus 1 bar is equal to 0. That is j is equal to 1 and k is equal to 0. So even though these outputs are taken here, even though these outputs are taken here, but they are not going to change the output of this slave, because slave will be in deactivate mode up to 100 nanoseconds. That is end of the clock pulse, the slave will be in deactivate mode. Why? Because slave changes its output in the positive edge only. Okay, so for the positive edge only. So if the clock pulse is like this, so if this is your positive edge, negative edge and positive edge, so at this negative edge, if you have given j is equal to k is equal to 1, right, in order to change that, okay, so in order to change the output, but for this total duration of 100 nanoseconds, slave will be in deactive state, because slave will activates only on positive edge. So at this stage only it will be there, it will be activated. Okay, so then j is equal to 1 and k is equal to 0. These inputs are applied to slave and corresponding output will be obtained at this master slave flip-flop. Right, so thereby, even though once you got this 1 0 and after 10 nanoseconds again if you have changed it to 0 1, that will not be copied, because once the data is transferred to this flip-flop, it will be get stored, but the reflections of the output will be changed only at the positive edge. Okay, so the reflections of the input will be changed only at corresponding edges. That is what I have told you, edge triggered flip-flops. Okay, so this is 0 1. So even after 10 nanoseconds, even if toggling occurs here, that is race around condition occurs in the master flip-flop, it doesn't get affected because slave is in deactivate mode. Right, so thereby you will have the stable output. You have the stable output at the output of master slave JK flip-flop, and thereby race around condition in JK flip-flop can be eliminated. Okay, so that is the thing here. Right, so output is also same. So when j is equal to, suppose if you have qn is equal to 0 and you are giving j is equal to k is equal to 1, you expect that qn plus 1 is equal to 1. So same, when j is equal to 1 and k is equal to 1, so output is always obviously 1. So you'll get the correct output and you'll get the perfect output by eliminating the race around condition. The important point which you have to remember is, this is asked in SSC JE exam. Right, so recent SSC JE exam. So output of master slave flip-flop is output of slave flip-flop. So output of slave flip-flop is the output of master slave flip-flop, but not the output of master flip-flop. Okay, so understand the difference. So output of master slave flip-flop is the output of slave flip-flop, but not the output of master flip-flop.